Hi guys, welcome back to my inverse trig function section. So in my last video, we kind of looked at the sine inverse function and the domain and the range, and we tried to kind of understand what is the domain and what is the range and how do we restrict the domain and range. Guys, here I already have the domain and range for all the three trig functions. Guys, you can find the rest of them in your textbooks, but these are the most important one and most frequently used one. There's the sine inverse function. We already discussed that in my previous video, guys. Then the same thing, you can use the same idea, same concept to find the inverse of the cosine function, and then also find the domain and range for that case. Guys, the domain for both the cosine and sine is basically going to be the same, but the ranges are different. Guys, then for the tangent, again, the domain is different from the previous two. And range is almost similar to the range of the sine inverse, but here the endpoints are included, here endpoints are not included. Guys, this is not too difficult to see why this is true. You can just look at the graphs of tangent, then restrict it, and then because it has to pass the horizontal line test for us to be able to find or to draw to get the inverse of that. Guys, once we have the graph of the inverse tangent, then you can see from that why the domain is all the whole real number plane or near number line, sorry. And then the range is, why is range restricted between negative pi over 2 and positive pi over 2, but the endpoints are not included. Guys, that is something that you must do looking at your textbook. Now, based on this and based on unit circle, or if you want to remember the special triangles, we want to now look at some examples how to evaluate the inverse of some trig functions. So guys, let us look at some examples here. Example 1, how about we want to evaluate sine inverse of negative radical 3 over 2. This is the first example. So how do we actually do this? How do we find that value? Guys, first of all, we have to kind of go back and remind ourselves that this basically finding the value for this trig inverse function is basically finding the value of that angle theta, if you like to think in terms of theta, or finding the value of that angle for which the sine of that angle is negative radical 3 over 2. Okay, but there's something more that one has to keep in mind. We don't have to look for that angle in this whole unit circle, guys, because the range is restricted between negative pi over 2 and positive pi over 2. So that means we're only interested in, so let me again redraw. So you're interested only in this section. This is negative pi over 2 to positive pi over 2. So I'm only looking at what? The first quadrant and the fourth quadrant. First and the fourth. Guys, what actually tells me to only focus on the first and fourth is the fact that the range for the sine inverse is only restricted between negative pi over 2 to positive pi over 2. Keep in mind, and I should actually draw those dotted circles here, which tell me that endpoints are also included. So guys, I like to draw this for reference once I have the actual domain and range, but it is also helpful to kind of draw this for reference. Once you are confident with these examples, then you know what you're doing. Then it's up to you then if you want to draw this or not. Now, since we are only restricted in the first and the fourth quadrant, that makes life even much more easier. All I'm going to do now is I'm looking at my unit circle and I'm seeing where is the sine negative radical 3 over 2. Keep in mind, the sine, if you are looking at the unit circle, the cosine is the x coordinate and sine obviously is the y coordinate. Guys, I'm looking through all of these, and you know what, even I already know one other thing, that it's a negative value. So we know that sine is positive in the first quadrant, but sine is negative in the fourth quadrant. So obviously we cannot find the value for that angle in the first quadrant. It has to be in the fourth quadrant, right? If we have to only choose between first and fourth, it has to be in the fourth quadrant. And I can easily see that in the fourth quadrant, that angle is negative 60. So it is this angle right here, guys. There's a point right here which gives me 1/2 and 1/2, and what else? I have negative radical 3 over 2, and that is the angle. And guys, this angle, I want to make sure I don't make a mistake here, guys. This angle is 60 degrees. But keep in mind, this is in the this is below the x-axis, so we are not going to use a positive 60, we're going to use a negative 60. So the value for this is negative 60 degrees. And if you want to have it in radians, then it's going to be negative pi over 3 radians. Let me make sure that I have the same thing. Yes, that's the same thing I have in my notes as well, right? So guys, that's basically how you evaluate the sine inverse or inverse of a trig function. Okay. Now guys, if you do not have a unit circle with you, then you have to rely on the special triangles and draw some reference triangles and go from there. Okay. But right now I'm assuming that everybody has access to unit circle, so you can look at the unit circle for this. Guys, number 2. How about cosine inverse of, let's say, radical 3 over 2? Now to evaluate this, again, we know we have to find the angle for which the cosine of that angle is radical 3 over 2. Keeping in mind that it is restricted between 0 and pi. So the first thing that you can do here is, again, it's optional. I'm going to draw the range so that I can see where I have to look for the angles. So again, I don't have to, you can look at all of these 3. You can see that they are not valid. The range is not valid for all the 4 quadrants. It's only valid for any 2. In this case, it is between 0 and pi. This is my 0, this is my pi. And the endpoints are included. That's okay. Sometimes we may have values which are lying on the endpoint. So we got to use them. For both sine and cosine, and it touches the endpoint. Guys, I only have to look for the values in here. But wait a minute, I already know this is a positive radical 3 over 2. I know all the angles are positive, right? All the values are positive here, or sine, cosine, all the trig functions are positive here. In the second quadrant, only sine is positive, cosine is negative. So it cannot be in the second quadrant because this is a positive value. That means all I have to look for this angle is in the first quadrant, which actually even makes life much easier for us. So I'm going to again look at my first quadrant, and radical 3 over 2, keep in mind guys, cosine, we're looking for the cosine of the angle. Cosine is the x coordinate, and I can clearly see that it is right here, this angle right here, which is 30 degrees, and the values are radical 3 over 2 and then 1/2. I'm interested in the cosine, so it is going to be 30 degrees. So guys, this is going to be pi over 30 degrees if you want to keep it in degrees, which is same as pi over 6 radians. That is example number 2. Guys, let us look at another example with the cosine inverse. How about cosine inverse -1? I want to talk about some endpoints as well. I already have the restriction for the range of the cosine functions. -1, guys, -1, we know cosine is positive in the first quadrant. For that matter, all the trig functions are positive in the first quadrant. Cosine is negative in the second. Well, it is negative in the third as well, but here we don't have to worry about the third or the fourth. It's only restricted in between first and second, although endpoints are included. So I'm again going to go back and look at my unit circle, and looking at the unit circle, I see that at this point right here, pi, the coordinates are -1 and 0. This is my x coordinate, which is the cosine, so it's going to be just pi radians, or which is same as 180 degrees. That's how you would find the cosine.